What if our universe isn't what we think it is? Recent findings from the James Webb Space Telescope have forced scientists to reconsider some of the deepest assumptions about the cosmos. Among its many discoveries, one in particular stands out: a strange and persistent pattern in the way galaxies spin. For decades, cosmology has been guided by a powerful principle, that the universe is isotropic, meaning that on the largest scales, it looks the same in every direction. Galaxies should form randomly, with no preferred spin or orientation. But Webb's observations suggest something very different. A majority of galaxies seem to rotate in the same direction, almost as if the universe itself is aligned by an invisible hand. This subtle imbalance raises profound questions. Could there be a hidden structure woven into the fabric of space-time? And if so, what does it tell us about the true nature of our universe? The James Webb Space Telescope was designed to peer farther into the past than any instrument before it. With its golden mirrors and unmatched sensitivity, it looks across more than 13 billion years of cosmic history. It captures galaxies as they appeared only a few hundred million years after the Big Bang, when the first stars were forming, and the universe itself was in its infancy. In one study, led by astrophysicist Laura Shamir at Kansas State University, Webb was used to examine 263 galaxies from this ancient epoch. What the researchers found was striking: about 60% rotated clockwise, while only 40% rotated counterclockwise. On the surface, this might seem like a minor imbalance. But in cosmology, such patterns carry immense weight. If the universe were truly random and uniform, galaxy spins should average out over large scales, with no preferred direction. Instead, what we see is a cosmic tilt, a bias that suggests some hidden order at work. This isn't the first time hints of such asymmetry have appeared. Earlier surveys with the Hubble Space Telescope suggested that galaxies may not be distributed as randomly as once thought. But Hubble's data was limited, leaving open the possibility of coincidence or error. Now, with Webb's unprecedented resolution, those patterns are harder to dismiss. The implication is profound: the early universe may have been born with a directional imprint, a kind of cosmic handedness that influenced how galaxies formed and spun. One of the most intriguing explanations for this alignment comes from a bold idea known as black hole cosmology. According to this theory, our universe may actually exist inside a massive black hole that resides within a larger, parent universe. In this framework, the Big Bang wasn't the absolute beginning. Instead, it was a bounce, a violent collapse of matter that rebounded, creating a new expanding spacetime. Black holes, far from being dead ends where matter and light vanish forever, could instead be gateways to entirely new universes. If our universe was born from a rotating black hole, that rotation could have been imprinted on the fabric of spacetime itself. The galaxies we observe today, spinning preferentially in one direction, may carry the fingerprint of the black hole that gave birth to us. This idea is more than speculation. Extensions of Einstein's theory of general relativity, such as Einstein-Cartan theory, predict that under extreme conditions, collapsing matter does not form a true singularity. Instead, the presence of quantum spin may cause matter to rebound, igniting the birth of a new universe. Even some of the biggest puzzles in modern cosmology, such as the Hubble tension, the conflict between different measurements of the universe's expansion rate, might find an explanation if our cosmos is the child of a black hole. And Webb's discovery of massive, mature galaxies surprisingly early in cosmic history could make sense if some structure or matter was inherited from a pre-bounce universe. If this hypothesis proves correct, it would mean that our universe is not a one-time creation, but part of a much larger cosmic cycle. Black holes could be cradles of creation, each one giving rise to new universes with their own unique properties. It would also redefine our understanding of the Big Bang, not as the beginning of everything, but as the transformation of something older into something new. In this view, universes may be born, live, and die, passing their fingerprints down through the spin of galaxies and the structure of space itself. But extraordinary claims require extraordinary evidence. The study of 263 galaxies is a strong beginning, but it is far from conclusive. To truly understand whether this bias is universal, scientists must study thousands more galaxies, scattered across different parts of the sky. And they must rule out other possibilities. Could Webb's instruments create subtle imaging effects? Could our position within the Milky Way distort the way we interpret galaxy spins? These questions demand careful, methodical answers before any bold new theory can stand. The James Webb Space Telescope is still in its early years of exploration. Its deep-field surveys will reveal thousands more galaxies, reaching farther into the past than ever before. With each new image, we gather more clues about whether this mysterious spin alignment is real. At the same time, cosmologists are rethinking the fundamentals of their models. If the universe is not isotropic, if it carries a preferred direction imprinted from birth, then the standard cosmological model may need to be rewritten. Researchers are also searching for relics of earlier cosmic cycles, primordial black holes, subtle patterns in the cosmic microwave background, or traces of matter carried over from before the Big Bang. Any of these could lend weight to the idea of a bounce, and to the possibility that our universe is just one of many. So we are left with a profound and unsettling question: could our universe exist inside a black hole? For now, the evidence is incomplete. The strange spin of galaxies may yet prove to be coincidence, or an illusion caused by the limits of our instruments. But if it is real, it points to something extraordinary, a hidden order that runs deeper than the randomness we once believed in. Imagine what that would mean. The Big Bang would no longer be the absolute beginning, but the continuation of an eternal cycle of collapse and rebirth. Every black hole we see in the night sky could be the seed of another universe, each with its own stars, galaxies, and perhaps even life. Our cosmos itself may be the child of a greater reality, born from the ashes of another world. And if that is true, then we are part of something far larger than we can comprehend, a chain of universes, stretching beyond imagination, connected through the silent engines of black holes. In this vision, creation is not a single event but an ongoing process, repeating endlessly across the fabric of reality. The James Webb Space Telescope is only beginning to reveal these mysteries. With every deep-field image, every distant galaxy captured in its golden mirrors, we step closer to understanding the origins of our universe, and perhaps, the universes beyond. Could the spin of galaxies be the clue that unlocks this mystery? Could the simple direction of their rotation carry within it the fingerprint of a cosmic parent, the evidence that we are living inside the heart of a black hole? These are questions without answers, for now. But one thing is certain: as we look deeper into the cosmos, the universe is forcing us to challenge our oldest assumptions. It is showing us that reality may be stranger, more complex, and far more beautiful than we ever imagined. And maybe, just maybe, the story of the universe has only just begun.